You can now put one AI in charge of the others inside Herdr. It opens their windows, hands out the jobs, watches which ones get stuck, waits for them to finish, and reads the results back. 15 of them, one screen, free. The only thing left for you to do is say what you want. So how much of a game changer is this actually? Because that depends entirely on one detail. Can one agent actually tell whether the agents it started are doing the job? The answer to that only matters if you are already running several coding agents at the same time. If you just run one agent in a single window, none of this changes anything for you. Far from being a clever user workaround, the vendor's own documentation actually opens by stating the tool is built so one model can create work for other agents. The system relies on 3 specific building blocks to make this happen. You have the layout to define the screen space, the raw terminal to run the commands, and the recognized agent that actually does the work. They separate the automation out this way because starting a new AI always requires an existing terminal to live in, and the agent never rearranges the workspace or manages its own windows. Because the runtime holds everything in place without asking the AI for help, one central model can easily start other agents in the background. It can check on how they are doing over time, and then pick up whatever they produce when they finish. That confirms this kind of central control is exactly what the product was designed to do, rather than an accident of the architecture. But reading about the concept in the manual is entirely different from understanding the actual mechanics of the handoff. That leaves the obvious question of what one agent commissioning another actually involves, step by step. To pull this off, the tool ships with an instruction file that teaches an agent to drive it, and the handoff is 4 moves that mirror how a human developer delegates a job. First, your main agent opens a second terminal right beside itself, and then it starts a completely different agent in that window. Because the terminal doesn't care who makes the model, your primary agent can start a rival vendor's AI, so you could easily have Claude open Codex to handle a stubborn Python script. In the vendor's own documentation, the main agent uses this to create work for other agents by starting a second agent that it names the reviewer and handing it the current diff of your codebase. From there, the first agent blocks and waits for the second one to finish, reads the answer back, and uses that text to keep moving, meaning it delegates the hard work and takes all the credit. You now have a chain of command where the models manage each other, which leaves you with the obvious question of why you would actually want a whole crew of different models running at once instead of paying for one really good agent. Herdr splitting work across a crew of different models is mostly about running several jobs at the same time, because when you have a few agents coding at once, keeping track of them becomes an immediate bottleneck. The alternative to a central dashboard is checking every terminal by hand to figure out who's stuck and who's still working. You could throw them all into the tools people already use to manage background processes, and third-party tests confirm those older tools tie on durability if you only want to keep the work alive. But a regular terminal tells you nothing about the agent inside it, which means you have to babysit every window to find out if a model needs your input or if it crashed. Herdr pulls that live agent state into one place, so instead of flipping through tabs, you go straight to the specific model that needs a human. That clears up the workflow, but it still leaves the door open on whether this is a brand new idea or a fresh coat of paint on a concept developers have been using for decades. If you read through the dev write-ups, the most common reductive framing is that Herdr is tmux for coding agents. It's easy to see why people jump to that conclusion, because instead of some heavy desktop application wrapped around a browser, it's just a single small download written in Rust. Reviewers group it with the agent multiplexer family of tools, which just means it splits a single window to manage multiple active sessions, running directly inside the terminal you already use rather than replacing it. That familiar footprint is precisely why the idea that it's just a skin is so tempting, and precisely why it's wrong. Because it kept the old shape while adding the one thing the old shape couldn't do. The older tools have no idea an agent is even there, which means you still end up acting as a tired human router just to copy and paste text between tabs. The part that's new here is that one agent can speak directly to another, so the strongest dismissal of the premise fails, and the premise stands. If this is a new capability, that leaves the open question of how many people have actually picked it up. If this is a new capability, the obvious next question is whether anyone is using it. And if you look at the official repository at the time of writing, Herdr is sitting at 31,500 stars. But a GitHub star is just a developer bookmark. So the important metric is that it already has 2.2K forks. That means thousands of people aren't just passively watching the project. They are actively pulling the code down to build on top of it. And they are doing that because of how the tool positions itself, which is written right there in the main description, where it claims to be the runtime your coding agents live on. But a free open source project catching fire this fast creates a problem, which is figuring out exactly who is behind it and what happens to all of this local infrastructure when the money arrives. The answer to that is they just went through Y Combinator, which changes the math on how long this project might stick around. When a free tool enters a startup accelerator, the fear is usually that it gets locked behind a subscription. But their stated plan is that the core runtime you install locally stays open, while they build paid features on top of it to keep the lights on. And they are moving fast to clear away friction, which is why native Windows support is now generally available. So you now have a funded, natively supported terminal where one manager agent can sit at the top and see every other agent at once. But if you think about how these isolated terminal agents work, a technical question opens up, which is what that manager is seeing. So if the manager agent can see every other worker in the terminal at once, what is it looking at? The answer is that the tool positions itself as the layer underneath the terminals and the agents running in them, rather than another application on top. And it builds everything around tracking one specific agent state per terminal. Every decision your crew makes about who gets a new prompt, who gets left alone to work, and who counts as finished passes through that one reading. Nothing else in the chain ever steps in to double check that status. So the manager accepts whatever the terminal says is happening like a rubber stamp boss, and keeps the whole machine moving forward. If the status says a worker is ready, the manager believes it and fires off the next command. But if the entire system takes that reading at face value, what is the crew's trust built on? And does any of it hold without a human watching? So what happens to this whole crew when nobody is there to watch it? Because the terminal window you're looking at isn't the real application. It's a viewer. The work is being held by a background service that owns the real terminal sessions, which means if you accidentally close the window or your internet connection drops, the agents don't care and the work survives the disconnect. You can reattach to the session hours later, either from the exact same machine or a different one, by running a remote flag. This unattended stretch is exactly where that status reading stops being a nice visual convenience and becomes the only source of truth you have. For long stretches of time, you aren't watching the agents type at all. So when you finally do log back in, you're dependent on whatever state the tool decides to report. You have to take that reading on faith to figure out if your reviewer agent finished the job, or if it's been sitting there burning your API credits while you were asleep. That leaves one gap when you think about it. So where does that status come from in the first place? For a small minority of the tools on the roster, the agent has proper lifecycle hooks and reports its own state directly to the manager. But for the majority of rival agents, that just isn't happening. Whether you are running Claude Code, Codex, the GitHub Copilot CLI, or Cursor agent, nothing is being reported by the underlying program at all. So instead, Herdr has to figure out if they are finished the same way a human would. Because these agents lack a real status output, the manager identifies the running process and then grabs a live bottom buffer screen snapshot to read the text straight off the terminal. It takes whatever it finds at the bottom of that window and matches it against pattern files, which is how it can centrally control more than one coding agent. But those matching rules are fetched automatically from the vendor's site. What counts as finished for the agents on your machine is decided by a rules file that updates itself from somewhere else. If the screen text matches a known progress indicator, it marks the agent as working. And if it matches a known error string, it flags the whole session as blocked. The complication here is that the blocked state only fires on a recognized screen. So if an agent fails weirdly, gets stuck in a loop, or prints something the pattern file doesn't expect, nothing in the rules will match. When that happens, it can't leave the status blank, so the system falls back to idle. It papers over the confusion by guessing that the agent is ready for more work, even if the underlying process is hung. So the entire premise of one AI reliably supervising a crew of other models rests on reading their screens. And when it can't understand what it reads, it assumes everything is fine. If ready can be wrong, where does the chain actually break? It usually breaks the second the supervisor tries to create work for other agents that are stuck on an unexpected terminal confirmation. Because if that second agent is sitting at a simple yes or no question it doesn't know how to answer, the incoming prompt from the manager is refused outright before a single character gets sent over. And the situation actually gets worse if the prompt does go through. Because if the other agent's screen doesn't show a visible change within a few seconds, the tool just drops the request entirely instead of waiting around for it to process. Which becomes a problem once you realize the automation wait commands themselves have no default limit, meaning an unattended supervisor can just sit there waiting forever for an answer that is never coming. So the reality of this unattended chain is that it has several invisible walls where it stops dead without telling anyone. And if you open up their public tracker right now, you'll see a constant stream of new issue reports logged against exactly these mechanisms. People are in there right now trying to untangle broken session resumes or weird rendering glitches, alongside state detection that just completely gives up in the middle of a long run. Which leaves us with a real gap in the pitch, because if the core reliability of the tool is actually this fragile, is the vendor pretending none of this is true? If you look at the instruction file they ship to the agents, it carries a hard gate that refuses to do anything at all if the agent is not running inside Herdr. They tell the AI not to start a crew merely because a task might benefit from parallel work, which means the agent is banned from using its own initiative unless the user explicitly mentions Herdr. So the honesty about the current limits is the vendor's own, and the real argument happening around this tool right now is mostly about what happens next. Because if you scroll through the Hacker News thread about their Y Combinator batch, you'll find half the crowd arguing that the terminal category is already crowded, and the other half is waiting for a rug pull, carrying this recurring worry that because they've taken venture funding, this free runtime is following the classic startup pattern where open beginnings tend to close up the second an investor starts asking about revenue. The vendor is owning their technical rough edges, while the internet argues about the business model. So what is the honest size of the change? The underlying commission mechanic is real, and the official documentation advertises that you can have one agent create work for other agents. You can build a cross-vendor crew where one model delegates tasks to another. But the glue holding the entire operation together is terminal text. Because there's no universal protocol tying rival companies together, the supervisor only knows a worker is done by taking a bottom buffer screen snapshot, meaning the size of the change is the size of what a single screen can show. It's a clever way to run more than one coding agent in the same view, but since it relies on a visual pattern match, you still have to intervene the minute an output format changes or a status read fails. You haven't been automated out of the development loop. You've been promoted from typing out the code yourself to acting as the middle manager for a team of digital juniors that occasionally stare blankly at a wall. Your job is still to watch the screens, debug the handoffs, and figure out why the Claude agent is waiting for a Codex agent that gave up an hour ago. The human moved to the top of the loop, but you're still in it. Anyways, that's all, folks.